Hello aspirants, welcome back to another session of Assistant Electrical Inspector. So today we are going to discuss about some basic electrical engineering. Okay, so without wasting any time, so first thing we'll see what is electrical energy. Okay, what is the specialty of electrical energy. So if we talk about the specialty of electrical energy, it gives interconvertibility, transportation and flexibility in the world. Okay, if we talk about interconvertibility, you might be asking, sir, how it is in interconvertibility. Okay, so here electrical energy. Okay, so how we are converting electrical, how we are getting electrical energy, first we will listen. Okay, so mechanical energy is converted into electrical energy, correct? Likewise heat energy, solar energy, wind energy, chemical energy. Likewise, the same electrical energy is converting again back into mechanical energy, heat energy, correct? So mechanical energy, say try your suppose your motor pumps in your houses, heat like heaters, light your incandescent bulbs, LED bulbs, whichever are there in your home. Likewise wind, take a example of a fan, chemical, likewise a chemical. So again, if we talk about interconvertibility, we have very flexibility in interconvertibility of energy in one form into another form. So we have transportation. Okay, generation and transportation, if we talk, we can generate the electricity in bulk quantities, we can transport them in longer distance. See, our India is a one nation one grid, having thousands of kilometers of transportation of electricity overhead via overhead lines and underground. Okay, and it is most economical way. Okay, so if we talk about electrical and electronics engineering, we will deal with power level. Okay, that is kilovolts, kiloamps, megawatt or gigawatt with the frequency of 50 hertz. Okay, if we talk about electronics and communication engineering, they will deal with signal level, that is millivolt, milliamps, milliwatt or watt, and they have wide range of frequencies, correct? Kilohertz, megahertz, gigahertz, likewise. So considering all these things, parameters are different for performances, correct? For power level and signal level. If we talk about the power level, what are all the major parameters we are looking into it? Okay, cost matters, efficiency, percentage of voltage regulation, we have to take care of losses, we have to maintain the power factor and improve the power factor. To improve the power factor, we are connecting some condensers, correct? We have different power factor improvement devices. Protection, yes, switch current protection by inserting some circuit breakers and fuses. Reliability, we have to check with reliability, and safety also matters. Okay, safety, wearing hand gloves and keeping some warning signs or boards. Okay, if we talk about signal level, what they are dealing with precision, accuracy, portable. See, electronic components or gadgets are very compatible or portable, you can take anywhere. See, if you take a charger, okay, it is portable. What it is doing, it is charging your device, you can take it from one place to another place, and it is compact. The charger is very compact. In earlier days, there you see phones, how bigger was phones, correct? Cell phones and all, landline. Okay, and speed, this also matters in signal level. Okay, so today we are going to just discuss what is basics. Okay, to understand the electrical energy, first what we should know, notations and maths. This is important in our electrical energy. To understand electrical energy, notations and maths, that's it. So if we talk about the notations, see, source, we will notation for source is like this. Okay, so current is going outwards, that means it is a source. Okay, if the current is coming inwards, it is called sink. Okay, so this is a magnet, we can represent like this. It is going from north to south. Okay, coming out from south to north, like that. If you talk about ampere right hand thumb rule, so current is going like this and motion is like this. So this is the IEEE notation. Okay, any material in electrical we are representing, see R, L, C are there now. R represent linear time invariant. Okay, that is electrical property of a material. Resistance is electrical property of a material. Likewise, inductance and capacitance. What inductance represent? Electromagnetic property of a matter. Likewise, C represent electrostatic property of a matter. So including all these materials R, L, C, and practical example is transmission line. See, transmission line have different parameters like R, L, C in it. Okay, so engineering is the application of science and modeling our applications mathematically to do analysis. This is what engineering. So if we talk about, see, first we will know what is the difference between circuit and network. Okay, so this is a circuit and this is a network. You might be wondering, it looks same, correct? So here if we talk about the circuit 1 or the diagram, circuit diagram which I have drawn here, so here current I is intended to flow through all the components. Okay, this 1 ohm, 2 ohm, 3 ohm, 4 ohm, etc. Okay, so here if you talk about the network, here also the current is flowing, here also it is flowing, but here current cannot flow because it is open circuited. Okay, so any of your friend comes and says here the circuit is closed, here the circuit is closed, current is flowing, why not here? Then tell him to hold the two ends of the wire, it will flow through him. Okay, jokes apart. So here all our electrical or all our practical big interconnection systems are networks, but that part where current is flowing, as I said, the part where the current is flowing and energy conversion takes place is called a circuit. Okay, whereas circuits are building blocks of network. Many circuits are building blocks for the network. See here circuit, and here we have a element, it is making a network. Okay, so if we talk about example, our power system is a big network, correct? We have n number of generating stations, n number of transmission lines, okay, overhead, underground, but the motor running at in it is a circuit at power level. Likewise, if we talk about our communication system, EC people, our communication system is a big network, but transmitter working in it is a circuit at signal level. Power level, motor running in it, signal level, transmitter working in it. Okay, this is what the difference between circuit and network. See, we electrical people are power engineering, circuit applications. Examples: transmission and distribution, fault analysis, machines, power electronics. Likewise, if we talk about electronics and communication engineering, they are studying signal engineering, that is network application. We are circuit application, EC people are dealing with network applications. Examples for network or signal engineering is Wi-Fi, Bluetooth, transmitter, etc. Okay, so if you talk about some network components or elements, all our practical applications are our components only. Okay, any components which are existing in the world are the network components or element. Okay, but when these applications are mathematically modeled as a circuit or a network, we use them as a fundamental element such as voltage, current, resistance, inductance, capacitance, etc. Okay, see, if we talk about the practical applications, see here I am showing in a diagram the using resistance. What application it is doing? Heater. Okay, you might be using water heaters in your home, correct, or a coil type heater. And if we talk about fan, single phase induction motor, correct, here we are including what? Inductor, here capacitor, okay, here voltage source. Okay, these are some practical application of where we are using network components, okay, or elements. If we talk about our power system or electrical energy system, okay, we should treat them as our family. Okay, an electrical engineer student should know electrical engineering is in our life. Okay, it's like a family and it is a life. Okay, in that voltage and current are like mother and father. Okay, resistance is a boy child, inductance and capacitance are girl child. So you might be wondering, sir, why only voltage is a mother and why only current is a father? Okay, so let me explain here why I am telling like that. See, sir, voltage and current, these are active components. Okay, remember this. Resistance, inductor and capacitance are passive components or passive elements. Okay, components and elements are one and the same. Passive component. Okay, see, sir, I'll tell you, voltage and current. See, in your family, without your parents you are nothing, correct? If your father and mother were not there, you are not there in this world, or you are not existing in this world. Okay, likewise voltage and current are having superior power. Combination of them is what? Power, bro. Power is equals to voltage and current, correct? They are having superior power, parents. Likewise in our electrical system, voltage and current are superior, that is active components. Resistance, okay, they are dead elements. Okay, until and unless active components are fetching or feeding some current or voltage to the component, they get energized. Okay, so why I am saying particularly resistance as a boy child? If we talk here, see what boy will do. So see, let's discuss some general topics. Okay, here, see, in your home you will be having brother, younger brother or elder brother. If a father or a mother gives 1000 rupees to him, okay, 1000 rupees to him, what he will do? The next day he will spend all the money, whole money he will spend. Okay, that means what it is he is doing? Dissipating or wasting. Likewise, what resistance will do? It will take the energy from active element. Okay, it will consume that and it will dissipate. Okay, see, in our home also we are using n number of energy wasting devices. That's why our electricity bill is going up day by day, correct? So the only property the resistance is having like this, it will dissipate and wasting the energy. But the same thing is not with the inductance and capacitor. See, sir, they are having superior power. Girls, we all know that. See, V is equals to L di by dt, we all know, correct? C is equals to I is equals to C dV by dt. Okay, see here, why I am particularly saying inductance and capacitance as girls is, Inductance, if you give the same amount to a girl, your sister, elder sister or younger sister, what they will do? They will spend 500 rupees tomorrow. They will store the 500 rupees for future purpose or in other purpose. Okay, they will spend next day. Likewise, what inductance will do? It will take the energy, okay, energy from the active source. It will store the energy. As I said, they will store the 500 rupees. Inductance will store the energy in the form of magnetic field. Likewise, capacitor will store the energy in the form of electrostatic field. Not only these properties are having by inductance and capacitor, they are also having different properties. See, here only you are seeing their mood will change. They will be having mood swings, correct? Their mood will change according to time. Okay, see, if I talk about girls' moods, sometimes they are over damped, sometimes they are critically damped, sometimes they are under damped. Like this, their mood swings comes. That's why we are comparing girls as inductance and capacitance in a family. Okay, this is for your understanding purpose. Okay, don't take it personally. Okay, if we talk about next, so in next lecture I will be discussing syllabus topics which are mentioned in the KPSC Assistant Electrical Inspector notification. Okay, so straight away we will start the topics. Okay, tomorrow I will be uploading part 1 video, so it will be in part 1 and part 2. Okay, I will try to minimize the time. See, why I am writing before and explaining after is to save the time, because we don't have so much time to write and explain. That's why I am doing like this. Okay, so if you like this video, please like, subscribe and share with your friends. Okay, soon I will be uploading different videos regarding electrical engineering. Okay, thank you for watching once again.